From the sluggish plod of feet to the speed of light, such is the story of the development of communication. For centuries, the speed of communication depended upon the speed of transportation. Bearers of news toiled across mountains, traversed vast open plains, treaded their way through deep forest, or tossed upon broad expanses of ocean. Often they encountered storms, observed the lightning in the skies. But they could not know that this was one form of energy which would shatter the barriers to human contact. The story of worldwide mass communication begins in the later 17th century, when Volta in Italy made a discovery of extreme importance. He developed the principles of the electric battery. Batteries make possible a continuous flow of electricity that moves with the speed of light. As a second important development, Watson in England demonstrated that electric current could be conducted from one place to another using the earth to complete the circuit. In the United States, Henry improved an electromagnet so that even a feeble current could produce considerable attracting power on a steel rod. And then another American, Samuel Morse, combined these three inventions: the electric battery, a conductor made of wire, and an electromagnet. By pressing a key, he started a flow of electricity from the battery through the wires. This caused an impulse to flash to the electromagnet at the receiving end. The impulse brought two pieces of metal together and produced a click. This is the original model of the world's first telegraph. In 1844, the first public telegraph message was transmitted over an experimental line between Baltimore and Washington, D.C. Here was a method of virtually instantaneous communication, the telegraph, a development of tremendous importance. Almost overnight, no news was farther away than the nearest telegraph key. The exciting drama of the opening of a new continent flowed across telegraph wires from the farthest outposts to the population centers in the east. And as the railroads went farther west, the wires of the telegraph followed, providing almost instantaneous communication between distant places. Only the ocean remained a barrier. In the 1860s, a difficult undertaking got underway. A submarine cable containing many telegraph wires was planned between North America and Europe. After many months of arduous work and after many breaks in the cable and fresh starts, Europe and America were finally linked by a continuous telegraph wire. The cable rested on the floor of the ocean and carried messages flashed by the keys of telegraphers on both sides of the Atlantic. But despite all this progress, messages could still only be conveyed as code signals. Then, in 1876, an American speech teacher, Alexander Graham Bell, came upon the idea that waves set up in the air by the vocal cords could be transmitted over a considerable distance. These waves caused a thin diaphragm to vibrate, which in turn caused variations in pressure upon a mass of carbon particles next to the diaphragm. These variations in pressure governed the amount of electricity passing through the wire. As these electrical variations arrived at the electromagnet in the receiver, they caused corresponding vibrations in another thin diaphragm. Sound waves set up in the receiver were similar to those set up by the voice in the transmitter. Bell's first apparatus was crude and weak, but it did carry his voice across the wire to a remote place where his helper heard the first sound transmitted mechanically. But many improvements were necessary to make the voice not only heard, but understood. The telephone as we know it today was born from these simple beginnings. With the years, shapes and sizes changed, but the same principle operates them all, carrying human voices wherever wires are strung. For both telegraph and telephone require wires. But inventive minds were already working on methods of communication that would not need wires. Marconi of Italy, elaborating the discoveries of earlier inventors and scientists, brought out in 1896 the first practical system of wireless electrical communication. The basic part of this development was the discovery that electromagnetic waves, which travel with the speed of light, can be sent out into space and then picked up at a distance by a receiving apparatus. Marconi's first message was picked up at a distance of less than 2 miles from its point of origin. Only 7 years later, wireless telegraph messages were being flashed across the Atlantic. Invention after invention piled up in the field of electric transmission. One of the pioneers, Lee DeForest, brought out a device called the vacuum tube. In it, a tungsten filament is charged with negative electricity and a plate with positive electricity. As the voltage on the plate increases, more electrons are attracted to the plate, thus amplifying weak electromagnetic waves. Vacuum tubes of all sizes soon crowded the nerve centers of communication. Thanks to the efficiency of the vacuum tube, a new voice began to fill our homes, the voice of radio. This is station KDKA, Pittsburgh, bringing you a program of news and music. The first commercial radio station in Pittsburgh opened a new era of entertainment and education over the airways. Transmission towers of all kinds, shapes, and sizes began to dot the countryside, and soon shortwave telephone messages were crossing the ocean to relieve the overcrowded submarine cables. But carrying human voices over the air was only the beginning. Hardly had radio established itself the world over when television joined the battle for the airwaves. Television went into millions of homes. Now the public not only hears but sees events as they occur. Entertainment, news, and education are flashed instantaneously from studio or location to television screens. Television transmission towers and cables rapidly spread over the American continent. Starting from the large populated areas of the East, the two coasts were soon locked in an ever-increasing network of cables and towers. But man's inquisitive mind never rests. The relatively large vacuum tubes make instruments bulky. Electronic engineers set to work to solve the problem of the size of vacuum tubes. The answer came in the form of the germanium transistor, a new means of controlling electronic impulses with instruments many times smaller than DeForest's vacuum tube. Thus, the pioneers in the development of electric communication, toiling through the past century, have given the world a nerve system whose messages travel with the speed of light. In our complex industrial society, the average citizen carries on a large part of his activities by telegraph or telephone. Unmeasurable as yet is the full effect upon our world of this instantaneous network of communication. Wire and wireless transmitters tie newspaper offices with points where news originates, bringing information by teletype into the newspaper headquarters, and carrying pictures by wire photo to the desks of newspaper editors. Airplanes carrying radio equipment and air bases equipped with radio and radar increase the safety and efficiency of air transportation. Radio brings aid to ships buffeted by stormy seas. Radio, television, teletypes, and wire photos disseminate important public information quickly to all the people throughout the nation. These marvelous electrical devices of the past century have so increased the speed of communication that we now have the means to overcome ignorance and isolation, and to transform the pace of the world in thought and in action from the sluggish plod of feet to the speed of light.